A 200-ton steel giant rises to 1,000 feet, building a skyscraper. Yet no crane on Earth can simply hoist it there. So how do these machines, the very cranes that define our skylines, assemble themselves higher and higher when even the world's largest cranes can't reach that high? This is the engineering paradox at the heart of unbelievable: how cranes climb themselves into the sky. The answer is a breathtaking system where the crane climbs its own frame, each new mast section hoisted and locked by hydraulic power with only inches to spare. If anything goes wrong, catastrophe follows. But when it works, it unlocks a world that ordinary machines could never reach. So, how does a crane build itself into the clouds? A tower crane at full strength weighs over 200 tons, more than a blue whale, more than a fully loaded Boeing 747. Its job is to rise 1,000 feet or more. But even the largest mobile cranes on the planet hit their ceiling at just 300 feet. That's the hard limit. No ground-based machine can reach higher without buckling under its own weight or running out of boom. The paradox is stark. The very tool needed to build the tallest structures is itself stranded by the laws of physics and steel. The city's next skyscraper can't begin its climb until someone solves the problem of lifting the lifter. This is the point where ordinary machines fall short, and the crane must find a way to build itself, one piece at a time, into the sky. A tower crane is a collection of specialized parts, each designed for a single purpose. At the ground, a massive concrete base anchors everything in place, weighing hundreds of thousands of pounds to counteract the forces above. Rising from that base, the mast is a lattice of tile sections, each about 10 feet square and up to 20 feet long, stacked and bolted one atop the next. Atop the mast sits the slewing unit, a machinery platform that houses motors, gears, and the turntable that lets the crane rotate a full 360 degrees. Extending outward, the long horizontal jib acts as the crane's main arm, reaching across the site to lift and move loads. On the opposite side, the counter jib holds up to 60,000 pounds of counterweights, providing perfect balance. Tucked between the mast and the machinery deck is the climbing frame, the hidden engine of the crane's ability to grow. The operator's cab, perched high above the city, is packed with controls, cameras, and climate systems, turning this steel giant into a precise, human-guided tool. Before a single steel section rises, the ground itself must be transformed. Engineers excavate a pit deep enough to anchor a small skyscraper, then pour a slab of reinforced concrete weighing up to 800,000 pounds. This isn't just a heavy block, it's a fortress, laced with a dense cage of rebar, each rod precisely placed to resist twisting and shifting. Soil tests dictate the depth and spread, ensuring the earth beneath can handle the crane's crushing load. The base absorbs every force the tower will throw at it, from the swing of the jib to the shock of a sudden stop. Without this hidden giant below ground, the climb above would be impossible. Inside the cab, the operator steadies his hands on the controls. Below him, the climbing frame locks onto the mast, hydraulic jacks primed for action. At the push of a button, thousands of pounds of pressure surge through the steel cylinders. The entire upper structure, the turntable, cab, jib, and 150 tons of counterweights, rises as one, lifted several feet into the air. A new 20-foot mast section dangles from the hook, guided into the open gap by the ground crew. Bolts are driven home. Wrenches torque them tight. The operator lowers the crane back onto its new backbone. In less than 2 hours, the crane has grown taller, ready for the next leap skyward. Wind at 800 feet is relentless, turning a slender steel mast into a swaying pendulum. A freestanding tower crane can only stretch to about 230 feet before the risk of collapse becomes real. Beyond that, it needs help. Tie-ins, engineered by structural specialists, anchor the mast to the rising building. Every 15 floors, a steel collar wraps around the crane and bolts to reinforced concrete slabs inside. Angled struts reach out like ribs, bracing the tower against gusts that could otherwise snap it in two. These connections transform crane and building into a single, wind-defying structure, stable enough to keep climbing higher. Carlos Ramirez grips the controls, watching storm data flicker across a small screen. At 800 feet, a 65-mile-per-hour gust slams the jib, setting off alarms. The ground crew radios a single word: hold. Ramirez locks the slewing brake, swings the boom into the wind, and waits. Every muscle tenses as the cab sways, steel groaning under the sudden load. For 40 minutes, the entire team holds their breath, radios crackling with weather updates and safety checks. No one moves until the danger passes. Operators like Ramirez know that a single missed signal or moment of panic can cost lives. In these moments, precision and trust are the only things keeping the skyline safe. Dismantling begins with the rigging crew reversing the climb. The crane lowers its own mast sections, one by one, until it stands at its shortest. The last pieces are carried down by hand or packed into a freight elevator, a quiet finish to a towering job. A modern tower crane can weigh over 200 tons and reach heights of 1,000 feet, far beyond the 300-foot limit of mobile cranes. Throughout this documentary, we've traced the evolution from early post-war prototypes to today's hydraulic self-climbing systems, technology made possible by decades of engineering trial and error. As documented in Hans Liebherr's original research and development notes from the 1960s. We've seen how each 20-foot mast section is added with precision, and how stability is maintained with tie-ins every 15 floors. Despite rigorous protocols and thousands of hours of operator training, the full details of some manufacturer safety systems remain proprietary, and accident investigations are not always made public. What's clear is that the ability of cranes to climb themselves has reshaped city skylines and made vertical construction safer and more efficient. The story of the self-assembling crane is not just about machinery. It's the documented intersection of ingenuity, risk, and the ongoing quest to build higher.